Hello?
Hello, hey, hi Nick.
Hi, Amon. How are you?
Good and you, man?
Good, I'm okay.
All
How
right,
can you
great.
hear me?
Yeah, I can hear you.
Okay. I did some of the problems already for the virtual lab. Can you help me
Right.
check them out?
I'll not be able to answer, but I'll be able to, help you with the material if you have any questions.
Yeah,
Because it's a
that's why I'm
graded
asking.
lab, right? Yeah,
Yeah.
right.
You're going to be available tomorrow too for more questions on this, right?
Yes, yes, sure.
Okay. So I want to make sure I'm doing it right.
Uh-huh.
How you doing so far?
Good, good, man. Let me show you the screen.
Yeah, I was checking my emails last night to make sure I got your notifications.
Right,
Sounds okay.
right. And then Nick, just so you know that this will be recorded and then uploaded on YouTube. Okay.
Okay, sounds good. The one last week you didn't record it and put it on YouTube?
Yeah, I don't upload everything. I mean, if I see something is useful for other students, that's when I upload.
Oh, like this is useful, right?
So yeah, if
So
this
that's
will be
why.
useful, so at the
Okay.
end I'll
Now
decide
for
and upload.
okay. Now like here for the data air table, I got numbers as you know that are close to 35. So I think
Right.
I'm okay with
Uh,
that part.
yeah.
But like when I got to the questions part, that's where I got a little bit confused.
Right. Right. Right.
As I want to make sure if this is the correct answer. I mean, I want to make sure that this is exactly what you're looking for.
Uh,
Because it says number one, when the volume is doubled from 15 milliliters to 30 milliliters, what does your data what does your
right.
data show happens to the pressure? Hint answer in words such as pressure is reduced by half, pressure is
Right. Right.
reduced
Right.
by, you
Right.
know. Use similar words, phrases to answer part A of questions. What I wrote down is when the pressure is reduced, the pressure goes down. Is that true?
When what goes down?
What's the pressure?
Uh-huh.
Is that
So
something that what you're looking for or no?
say
Something?
that again. When the pressure goes down?
When the pressure is reduced, pressure goes down.
No, no, no. That's very obvious, right? That's not what
Yeah.
we're looking for. We're looking for connection between volume and pressure. That's what we were looking for.
Okay.
Not pressure and
Okay.
pressure.
Okay.
Volume and pressure. That's what we're looking for.
Okay.
So when you're given that volume is moved from 15 to 30, then check in your table where you have the reported volume. Check
Okay.
that
Because
and see when it goes from 15 to 30, what happens to the pressure.
for like 15, we're at like 20.10 in the volume, and for 30, we're at 35.00 for the volume.
No, no, no.
Half.
Look for 15 and 30 of volume reported. I mean, like you probably have something close to 15. Like if you see here 14.84, and then you see here 29.73, those are the volumes they're talking about, not the
Oh.
first row of
Okay.
the second row.
Because I got for 10 15.22, and for the one that's close to 30, I got that's in like in the 25 milliliter section.
Yeah, so you don't worry about 25 section or 10 section. Don't worry about that.
Okay.
Worry about that number you got 15.22 and then the one which is close to 30 under volume reported. Compare
Okay.
those two volumes and compare the pressure in ATM.
Okay.
Those are
Okay.
the pressures that you're looking for.
Okay. Because we got those. Now, exactly what do we do now with those numbers?
So now look at the number. You see this is close to 15 and then this is close to 30. So if I
Right.
go from 15 to 30, I double the volume,
Yeah, you do actually.
right?
It doubles.
So what happened to the pressure?
It went up.
No, look at the first. This is the first. You're able to see my screen, right?
Yeah, I am. I'm looking at it
Yeah.
right now as
So
we speak.
if this is my first volume, 14.84,
Mm-hmm.
Then what is the pressure? What's P1?
Like 2.2999 etc. I got, but I got something similar to you. Like you
Yeah.
have
Right,
2.359. I got like
right. Look at the numbers that
2.23.
I have, and then you can do the same thing with your numbers.
Okay.
So look here on the screen, and then you see
Right.
here 14.84. This is the
Right.
volume. What is the pressure? 2.359, right?
Yeah.
And then if the volume went from 14.84 to 29.73, which is almost double, then what happened to the pressure? Tell me what happened to the pressure. Pressure went from
The pressure went.
2.359 to 1.177. So what's that?
It basically went down because that's
Went
it's a
down.
smaller pressure.
Right, right. So what is happening? If the volume is going up, pressure is going down. You see that?
Mm-hmm. Yeah.
That's what you have to explain on the first page. I mean, the question number 1, 2, 3, all of that is basically
So I would say.
related to that.
I would say, when the volume goes up, pressure goes down. Right.
Right, right,
Yeah. I'm just trying to make sure I explain this right,
right, right,
which makes sense. Why volume goes? Which makes sense why pressure will go down if volume goes up. I can just see
right,
that
right,
making
right,
sense.
right, right, right. So that's what you're trying to see in the data.
Now, one question I have also, Mom, because I started putting
Huh.
my ratios in for
Right.
for like B as
Part
well
B.
on this problem,
Right.
and I put for I went basically with the for like the 30. I guess I probably put it in wrong because I went again basically looking at the milliliters pressure right there. Um, I put down for 1.00276 over 1.741977. I'm not sure if that's correct or
So you
if I
took
did
two
that wrong.
pressures?
Yeah.
Yeah. So it's saying that if you take the pressure ratio,
Mm-hmm.
then support your answer for part 1. Like if
Right.
the so you have to compare your pressure 1 to pressure 2 and see what ratios you get.
Mm-hmm.
Okay. So if you
So
see that the ratio becomes half 0.5, or I mean, what you're gonna basically get is, let me rewrite this as, these are the ratios. I'm just giving you an example. Okay. You have to actually put the
right.
numbers.
Yeah, that's what I'm
So
doing right now. I just want to make sure I'm
right.
putting in the right
So if you
numbers.
do the ratio, it's 1/2, which means it went half, right? Which is equal to 0.5,
Mm-hmm.
right? So
Mm-hmm.
that's just one example. Okay. I'm not saying this is the answer.
Right.
So
Exactly.
you will have to compare your pressures that you're given, like your 2.359 to 1.177. You will plug in those numbers and see what happens. So this number may be half, this number may be 2. I'm not, okay. Like if we see the example that we are given, so if we look at these two pressure ratios, 2.359, so
Mm-hmm.
2.359, that's my pressure 1. If we compare that to pressure 2, which I think is 1.177, I think it was that.
Right.
Yeah. So if you divide these two numbers, you should get a number like close to 2. So it's telling me that my pressure 1 was twice as big as pressure 2. Or when I
Right.
wrote it the other way, you can also do P2 over P1 and compare that as well. If I do that,
Right.
then I have this, and I get 0.5. So I can say that my pressure went down to half. I mean, it was cut down by half. That's what you have to explain or show in part B.
Yeah, that's what I'm trying to say. That okay, that makes
Okay.
sense.
So what? So in part 1, you were actually showing in a sentence like what
Right.
is happening, like pressure reduced by half. Let's say you were going to say that, right? In
Mm-hmm.
part B, you're actually going to prove that with the numbers.
Right.
Okay.
Mm-hmm. And then it says, because then like number 2, I think it's a little bit different because again I put the ratios down already, and then I put down basically what happens when the volume is halved.
Right.
Um, it's saying right here when the volume is halved from 20 milliliters to 10 milliliters, what does your
Right.
data
Right.
show
If
happens
it
to the
went from
pressure?
20 to 10. Right. 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 So I don't have the number for 5, but if you are going to see your data, you're probably going to be comparing the one where you have volume 5. Your volume reported will be close to 10. So you're going to
Yeah, I
compare
have
that
that.
10,
It's
right?
9.73, and then
Right.
15 is actually close to 20
You
because
said you
it's
have
20.10.
9.73 here.
Yeah.
Yeah, so compare this number, this volume, to this volume 19.65 or whatever number you have, because
I
they
have
look like they're doubled, right?
I have 20.10. Is that close to 20 Ahmad
Yeah,
or no?
yeah, of course, yeah. Right? 20.10 is close to 20, more than 19.65. So you're going to take that number 20 and then you're going to take this number close to 10 and you see if volume was cut down by half, what happened to the pressure. So you must have a
Right.
pressure as well on in this box.
Right.
What's the pressure that you have?
The pressure I have for which one for 5
For
milliliters for
9.73.
9.73, I have 3.5982706.
Right. So you can see that here, that if my volume went from almost 20 to 10, so if it was cut down by half, my pressure doubled,
Right.
right? So you have to make these connections and answer these questions, okay?
Yeah, because that's what I wrote down when the volume is half, the pressure increases. But I'm trying to figure out like exactly how to put in the ratios correctly, so I can explain the sentence.
Right. So you have to figure that out. I've given you enough hint. I mean, not hint. I've actually shown you part B. That's
Right.
exact same thing that you have to do for all these questions. For question
Okay.
number 3, exact same. Now in third example, it's going from 10 to 30 instead of going from 10 to 20 or 20 to 10 or 15 to 30. It's going from 10 to 30. So it went tripled. So what do you think will happen to the pressure? Of course, it's going to cut down by 1/3, right?
Yeah. Exactly.
And so you should be able to show that from the numbers that you have. So you have to basically just take the ratios, P1 over P2, that's it.
Right.
Or P2 over P1, whichever one you
Yeah.
think is
Exactly.
easier to explain.
This is similar. This is still similar to our chapter 9 stuff, right? I'm on this lab. Would you say so or no?
Yeah, this is chapter 9, yes.
So,
This is
yeah.
chapter 9, like you can think of a lab for chapter 9. Gas chapter, right?
Okay. Okay. So, yeah,
Just give me a
that's not.
second, okay? Nick, Michael, you're
Yeah.
here.
Ask him.
If you're able
Yeah.
to hear, then you can ask me if you have any questions.
So far, no, thank you. I'm just watching.
Okay, okay. All right, Nick, I'll continue with you. You were saying something?
Yeah, because this doesn't seem so bad. The slide doesn't seem so
Right,
bad. I just want to make sure I'm doing the ratios correctly because that'll dock a
right,
lot of
right,
points up when I'm doing those.
right, right. Yeah.
Now,
Did question number 1 made sense to you? If question number 1 made sense, you should be able to do 2 and 3 yourself
yeah,
because they're
I
exact
just
same thing. You're just dealing
yes.
with different numbers. That's it.
So exactly, I'm on the greatest amount of pressure, like the greater number amount of pressure would go before the least amount of pressure, right in the ratio,
I mean,
right?
it's not important. I mean, that's not necessary. I mean, that's not necessary. So you can do it both ways. You see, when I when the volume is doubled from 15 to 30, so they're saying that when V1 was 15 and V2 was 30, then what happened to the pressure? We checked what happened to the pressure. Pressure went from, what is our P1 and what's our P2?
Yeah,
Tell
our
me
P1
for
is
right. Our pressure one was 2.359, right?
yep.
Again, these numbers are not 1530 exactly. They are like 14 point something and 29 point
Yeah,
something.
exactly.
And
Yeah, right.
pressure,
As long as you're close, then you can just basically round them up, right?
you're not rounding them up. You will not pick let me clarify that.
Okay.
Yeah, what's the first volume?
First volume I got.
14.84.
Yep.
No, see what we are trying to do is the volume is doubled from 15 to 30, right? Now we don't have numbers in our table that are 15 exactly. So we're gonna pick the closest number. And don't even think about these numbers in the front because these are not the true volumes. The true volumes are the volume reported. So those are the ones that you have to work with.
Right.
Okay. So when it says 15 to 30, you're basically looking at this number. This is close to 15 and this is close to 30. That's what you have to look at.
Right. Okay.
Okay. So your volume is 14.84. I already copied that. Volume 2 is 29.73. Okay.
All right.
So that's our volume 1 and volume 2, and those are my pressure 1 and pressure 2, right?
Right.
So the question says when the volume is doubled from 15 to 30, okay, all right, so we're gonna look here. My volume went from 15 to 30. What happened to my pressure? My pressure went from 2.359 to 1.177, right?
Mhm.
So we can see that our pressure went down. It was cut down by half, almost half, right?
Mhm.
Because if you
Yeah.
compare 1.1, like if we actually divide the numbers, if we do 1.177 divided by 2.359, we get a number 0.49, which is almost 5, right? 0.5. So it's showing us that when the volume is doubled from 15 to 30, then our pressure is cut down by half.
Mhm.
Okay.
Yeah.
Now, yeah.
Now for B, I did the math right now too to see the
Right.
pressure. And it said
Right.
it basically went up by 2, which is basically
So,
what we just said.
Nick,
That
so
the
Nick,
half.
you're saying what I'm doing here? I'm erasing the first one, the one that you were thinking you have to always put the bigger number in the front. You don't
Yeah.
have to do it that way, okay?
You can do it either way by what you're saying, because as long as you get close to half, then as long as you get half or something, that's what's basically explaining your ratio, right? For
Right,
the
right,
sentence above.
right.
Okay.
That's proving the sentence above, right? Mathematically, it's proving that actually pressure went half when the volume was doubled.
Right. Because that's what I just did right now. I divided those numbers that you just that I found for for my pressure in part 2B, and it gave me 2.
Oh, okay, so it went from 20 to 10, volume is halved, and your pressure went twice?
Yeah, it went twice up.
Right,
It went
right,
above because
right.
based on what I can see here, it went from 174 to 359. So it's basically saying it went up.
You mean 1.74?
Yeah, the
Right.
9.73, right there. I just did it with
Uh-huh.
that, and then I did it with the one that was close to 20, like how you said,
Right, right,
the pressure.
right,
And it
right.
said
So
it
you're gonna,
basically went up.
right, exactly. So, and then the same thing you're gonna do for part 3.
Okay, yeah, because I already did part 3, and that's pretty straightforward. I did it that way,
Right,
so
right. And then if you
I
go to
just want
next
to make.
page, right. Yeah, you were saying something?
Michael, have any questions or no?
What's that?
Does the other person have any
Oh,
questions?
I'm not sure. Michael, do you want to ask something?
No, I
Or
don't
just
have any
listening?
questions. I was
Okay.
just going over it. That's all.
Okay, sure. Okay.
Uh,
Yeah, you go ahead.
okay. Now, basically, what I was a little bit stuck on too, I did this one already too. It was number 5,
Number 5, okay.
and I did, the formula you showed me in dry lab, with the, I forgot the other one, milliliters to the one you showed me on Google. I forgot which one it was, honestly. The formula one they showed me on Google, how to just basically look up the ATP or something like that.
You mean the
ATM.
conversion?
Yeah.
Right.
And I got, because it's basically asking me right here, based on your extrapolation of your data for the largest volume you entered, what would you expect the pressure to be if the volume is increased to 40 milliliters? Explain in words and use pressure values to support your answer.
Right.
For that answer, I got 0.875071.
Okay, so I don't know the answer, but you will have to tell me how you got that number, and that's how we can tell. What's the number you got for
Because
40 volume? 0. What?
0.875071.
It sounds right to me, because if the volume will go up, the pressure should go down, and it is less than this 0.9948, so that does make sense.
Okay, because I did it the formula you showed me on Google, the conversion. I did it through that, which just did 40, then it gave me that.
What formula did I show? I never showed you any formula. I showed you the calculator for changing PSI to ATM.
Yeah, that's what I exactly did. That's why I'm
But
asking.
you don't need that here, right?
I don't think so. I just wanted to make sure.
So you're given volume of 40 mLs,
Mm-hmm.
and then you're being asked what is the pressure going to be,
Right.
right?
Uh-huh.
And then you have to just tell me if you already have two pressure and volume numbers, which you can pick any one that you want. You can pick this 35.19 as volume and 0.994 as your pressure. You can call that volume 1 and pressure 1.
Mm-hmm.
So let's say I pick V1 to be 35.19, 35.19, and then I pick pressure to be 0.9948. So if I have these pressure and volume, and I have a volume 2, can you find P2?
Yeah, I can.
Right? Yeah, so so you have to use your formula to get the answer here.
Okay. And that's
Okay. The second way is that you can look into the graph that you have made already. Using that graph, you're going to decide on the graph that what should be the pressure. You're going to look at your straight line curve. That's one way as well. This is the easier method.
right. I can understand that, why it makes sense that way. So,
And number 6 is the exact same as well.
yeah, because that one kind of actually tricked me based on the number. That's why I honestly didn't bother with that one real quick because of 2.5 milliliters.
So yeah, you do that yourself. The only thing is changing is V2 is 2.5 instead of 40.
Okay.
That's it.
Okay. So just try doing this with this, and I should get the proper number, right?
Right. Uh-huh.
Yeah, this is actually pretty fun. I'm on this. I thought I wouldn't like this lab, but I like this labs.
That's great.
Just to let you know. So if I have more questions, I can ask you tomorrow about this
Sure.
during your office hours.
Sure. Bring in the office hours.
So I also like to know a little bit more on the graphing on Excel because I tried to do that on my own, but I still
Right.
got a little lost, honestly. I
Uh-huh.
want to do that because that can be important. So
Right.
can I pull out my multiple choice worksheets for this chapter right now? Because I have a few questions on those as well.
Yeah, sure.
I'm almost done with this lab, and I saw it's due this Friday for us.
Yeah.
Right, for this class for the 38.
Right.
And you said that this will be a non-Canvas solution submission, right?
Right. Yeah. You'll see it on Canvas. You'll see it under assignments, I believe. So if you go to Canvas and you go into your class, you can go to assignments. And then within the labs, you're going to find that. Inside the labs, you're going to find Gas Law Virtual Lab under assignments. And then you click on that. It tells you the due date. And then
yeah, I saw it was April 12th because Canvas I checked my Outlook last night for Canvas, and that's what it told me. So I just wanted to make sure.
me check on a student view how it's going to look like.
Okay. That's a pretty picture that's on there, Amon. Just to let you know.
Is it?
Where is that at?
Which picture are you talking about?
The one you was on your Google right now? Yeah. Okay, so you can't see it basically from your
This?
side. Yeah.
Oh, that's Switzerland.
Uh, so you can't see it how the students is gonna be, right? The students.
Yeah, so that's how students. Yeah, so this is how you guys look at it. So if you think it should be under assignments.
Okay.
And
I think it's set up there, right? Virtual, I think it says up there.
oh yeah, right on top. So you're gonna go in there and then submit assignment.
Assignment.
And then you're going to upload your two documents. You're gonna choose file and then just upload.
Okay.
Your Excel and your Word file, and then you just hit submit.
Your Outlook. So submit it both at the same time.
Yeah.
Okay. All right.
Okay.
My question is like number 17 on the gas laws and stoichiometry multiple choice worksheet.
Number 17.
I'm still using the PV equals nRT formula, right?
You're given 444 grams of this, and then you're given, right, yeah. You have to first change. What did you do here?
I think I changed 444 grams into moles, right?
Right. And then?
So and then what I did was I turned that into moles. Then I turned 752 torr into atoms, or atmosphere, I should say.
Right.
ATM, yeah. And then I changed 22.0, of course, to Kelvin, because that's always a must.
Right.
And then once after
when you use PV skill nRT, what moles do you use? Do you use moles that you got from 444 grams?
Yeah.
So do you see the question says the volume of CO? What volume of CO, right?
Yeah.
So we need to use moles of CO, right? Not the moles of NiCO4.
Okay.
You see that? What it's trying to say? See, the question is saying that you have, it's giving you a reaction, right?
Right.
You're given 444 grams of this guy. So if you get the moles of this guy, then you have to actually go and find the moles of CO. And why is that? Because the question is saying what volume of CO is formed. CO, that's the gas, right?
Yeah.
This thing is not even gas, that's a liquid.
Yeah.
This is carbon monoxide, right?
Right.
So they're asking you what volume of this gas will be made. So when you're going to use PV is equal to nRT, you have to use the moles of CO and not the moles of this guy.
Okay, so basically, I'm gonna go from grams of NiCO4 to moles of carbon monoxide, right?
So you're gonna go from grams to the moles of NiCO4, and then from moles of NiCO4, you go to moles of CO.
Okay, so that's the way I'm supposed to do it, right?
Right.
Because that's what I did there, and I was like wondering what's going on here, you know? So okay, and then you said always Amon that had to make sure that these are balanced, right?
Yeah, you have to make sure that they're balanced.
On the exam, are you always going to give them to them balanced or no?
You have to always check.
Unbalanced?
You have to always check, yeah.
Is number 18 balanced or no?
I mean, you check, you tell me if it's balanced or not.
Because I see 2 nitrogens.
And
then I see 1 nitrogen on the side, but then I see 4 H's. And then
you see 2 nitrogens on both the sides?
Yeah, I'm seeing them now, yeah.
Right. Yeah, there are 2, right? This one and this one.
Yeah, that's what I'm seeing.
Right.
And then I see four hydrogens, but I'm seeing that they're in the waters as well. and then I
Right.
see the two oxygens. So yeah, they're balanced.
Yep. Usually, Nick, whenever you're gonna see like a number coefficient already in the equation, it's probably balanced. But
Right.
it's always better to confirm.
Okay. Are these ones a little bit different, Aman? Have we covered the numbers 27 to 29? You said to go up to 26, which I'm going to try on my own still.
Which ones? 27?
27 through 29. You said we are going to cover those in the class, like exactly
Yeah, we
what
already
those
covered them.
exactly about.
Did we? Yeah, we
So
already covered the partial pressure, right?
yeah,
Yeah,
you said
that's where those are coming from.
yeah, because you said that these I can do on my own. Because if it's basically the stoichiometry. It's right 24 and 25 and 26. Because you told me to start on those and stop there.
Yeah, 24, 25, 26 is not stoichiometry, it's partial pressures.
Partial pressures.
So, yeah, so first do your questions that we did in the class. First, try to make sense of them, and then do these problems.
Right. Because you said that, because you sent an email also on, when was it, Wednesday night or Thursday night, that you had some problems from the lecture that you recommended that we did before we did these? So that was an email I saw.
Email from where?
From Canvas?
You send me an email?
No, an email that you sent out.
Uh-huh.
It said, hi everyone. Here are the chapter 9 slides. Please work on slide 24 of CH9
Oh, yeah,
slides.
that. Oh,
The
you're talking
one
about
we
that.
sent in lecture.
Right. That's the announcement that I posted, yes.
Is that the one that, is that similar to these problems here that you're explaining right now?
I mean, yes, they're more similar to the problems where it says a gas collected over water.
Mm-hmm.
So it's more similar to those questions.
Okay.
Okay. So you're gonna see questions like that. We did a question. Let me put it up.
Yeah, but I'm checking my emails constantly, so I'm just making sure.
Yeah.
It could always be something important that's due or something involving the exam.
So
I just
do you remember this?
Yeah, I
We
remember
talked
you
about this in the
showing
class.
that actually.
Right.
Yeah.
And then we did this problem.
Yeah.
Right. Partial pressure and then moles of oxygens. So if you study this question first understand this question, and after that, do this one. This is the question I'm talking about.
Okay.
If you open the slides, it's not page 20, but page 24 on that slide. So follow that page number, page 24. If you download the slides from Canvas.
Right.
So yeah.
Just wondering, among which numbers stop with the stoichiometry of these? Like, what numbers start with like those similar problems like that one?
You mean
on this multiple choice worksheet?
for stoichiometry,
21
you're
through
asking
20.
me?
Like where do they stop at on this multiple choice?
You mean you're asking me stoichiometry, right?
Yeah, where do they stop
Yeah,
at? Like
number
what
20.
number would they stop? 20. So 21 and the rest are those problems that you studied on Wednesday, right?
Yeah.
Okay. So those shouldn't be too bad, I assume, right?
I mean, you gotta work on them and see
Yeah, I mean, of course,
how
I'm
you
going
feel
to do
about them.
the what's from the lecture first because I look back at my notes and study them real quick before I do those. That way it can actually make sense to me. And you said that after, if I finish this worksheet, like if these worksheets today, you recommend I start the book work, right?
Sure. After you finish.
Yeah, I'm sure that'll help me for the exam.
Uh-huh.
For chapter 5, you said there's not going to be no more exercises, right?
Yeah, I don't have an exercise for that, but you have worksheets.
Yeah, where's the worksheet for that?
Yeah, same place.
Campus, but which one is it under? But what's like the name?
I think thermochemistry.
Okay. Because thermochemistry and this chapter 9 stuff and like the ending of chapter 4 will be on this next exam in 2 weeks, right?
Right. Yeah, if you go to modules.
Mhm.
Okay, basically go directly to multiple choice worksheets. Yeah. So if you go down after gas law, you see next chapter, thermochemistry.
Right.
Yep. So that's what you have to do.
Okay. And then Lewis structure and electronic
That's later.
configuration.
That's later.
That's like chapter 6 and 7, right? And 8.
Yeah, chapter 7, 8. Yeah.
Okay. This week there's going to be a quiz, right, for chapter 5.
Yes. Yes.
Okay. And it'll be due on Monday before class, or when exactly?
Yeah. Yeah. It will do. That's how usually it is. I post them on Thursday and then before Monday, they're due.
Okay. All right. And then, but you also said to make sure that, like, always to make sure that these problems are balanced, right? For like the stoichiometry part
Trigonometry?
on
Yeah.
gas
Yeah.
laws.
Always.
If they're not, I have to balance them before I start the problem, right?
Mm-hmm.
That'll confuse me. So, yeah. So for number 18, it's saying what is the volume of gas as produced by the decomposition of 35 grams of NO2 at 525 degrees Celsius and 1.5 atm. So
Mm-hmm.
we have already our pressure, but we don't have our volume yet. We don't have our moles yet.
Mm-hmm.
I mean, we have our moles, but we have to figure that out. We have our
Yeah,
R,
you
we
are
have
given
our
mass. Right. Right. But keep in mind, this time it says volume of gas. And both of these
right.
things are gases, so you have to find moles of both and add moles of those together before you use PV is equal to nRT. Just keep that in mind. That you
Okay,
find
so
moles of both the gases, this
I
one
have
and
to
this
find
one.
the moles. Okay, that okay. So I have to find the moles of NH4NO2, right?
Right.
And what other mole I need to find?
What do you think? Because you gotta recognize these questions. You should be able to figure out when you look at the question.
Right.
You should be able to figure out what it's asking us. So it's asking us the volume of gas, which is produced. So you're looking on the product side, and you can see that both of them are gases.
Yeah, yeah, because I see. Oh, yeah, you're right. Because it says gases and it's just gas in parentheses.
Yeah. Yeah, it's not saying that only find for nitrogen or only water, but both of them. So
Right.
when you use your NH4NO2 grams, you change it to its moles, then change it to moles of nitrogen and water, both of them. And you can get those individual moles and then add them together to get total moles.
Mm-hmm.
And then use that in PV is equal to nRT.
Okay, yeah, that makes sense.
Okay.
Yeah, so once I get the moles for both, then I can use that, right, in this formula.
Yeah, you can use
What you're
that
saying.
moles to use PV is equal to nRT. But the N has to be the N of nitrogen and water both.
Okay. So
when you
this is
try
what we're
that
gonna
problem.
do. Just
Huh?
so when I do that,
Right.
you recommend when I do it, because you have to do both problems, so I have to get both moles. You said, right, for both gases on the right side.
Right, for both the gases.
So it's basically what's those? Is it so it's basically a limiting reactant problem?
Not limiting reactant because there's only one reactant, so you technically cannot call it limiting. But it's similar. I know what you're trying to say because you're going to moles of two things from one thing.
Yeah.
You can think that way, but it's not limiting reactant because there's only one reactant.
Okay.
But
That's
yes,
what I was
there are
trying
two
to-
products. Right.
Okay. Because there's two products here.
Right.
That's what I would
So you're
basically
basically
do.
going mole to mole, but you have to do it twice. One for nitrogen, one for water.
Mhm.
Or if you don't want to go that way, there's one more way. What you can do is when you're going from mole to mole, you see from ammonium nitrate, which is NH4NO2,
Right.
You're going from 1 mole of that to 1 mole of nitrogen and 2 moles of water.
Mm.
So total gas moles is 3 moles. From 1 mole, you go to 3 moles. So it's a 1 to 3 ratio. So that's also what you can do.
Okay.
So you can add the moles before the mole to mole ratio, before actually finding moles of each one. So there are two
Right.
ways of doing this. It's up to you which one you want to do.
Yeah. So I guess I basically did the rest of them and I got them correctly. I got I did 14, 15, and 16 as well. I just need to do the rest of them. So I'm almost done
Right.
with this worksheet.
Uh-huh.
Just want to make sure. I mean, if I did the other ones correctly and I got the answer, that means I'm pretty much starting to understand it, correct?
Yep. But once you do more of them from your textbook, just so that
Yeah,
you
because
know that you
that'll
actually
help me.
understand them.
That way it's exactly stuck in my head and how to do it.
Right. Do as many problems as you can. And once you're done,
There's
start again.
there's not an answer key in this for this chapter, is there? In our textbook?
I think at the end there is. At the very end, you're gonna find the key. It will only
What's
give you the
the
final
end?
answer.
Yeah, what's the ending though? Where's like what page is the ending key at? So that way.
That you will have to look for. I don't remember exactly what pages. If you open, you should be able to find at the end.
Okay.
I think we saw that last time as well. So at the very end of your textbook, you should be able to find that before the index. Yeah. So right here, chapter 9. Yeah, it's on page 1289.
Okay, that's good to know.
Mm-hmm.
You know. So we have 2 more weeks till our next exam, right?
Right.
Gonna go by quick.
Mm-hmm.
Now you're gonna give us a quiz also before our exam, or no?
Probably not. No, there'll be just one more quiz.
So just one for this week, possibly, or there's not one for next week since that'll be our week before our exam, or what do you think?
Right, probably. That's how it's gonna be.
Okay, well that'd be good, so that way we can just study
Uh-huh.
for
Right. Yeah, the week after that, I think that's when I'll be putting the. I told you I'll be doing the workshop, so I'll probably do that not this week, but next week when more students will show up because the exam, it will be a week before the exam.
right.
Yeah.
You said you're gonna do it on the Tuesday though.
Yeah, so I'm not gonna do it on Tuesday then because I don't think many students will show up this week. It'll be more if
You're
I do it
thinking
next week. I mean, not this week, but next week. I mean,
next
not the
week.
coming
You thinking of
Tuesday.
doing it?
What's that?
You thinking of doing it like on Friday or something, or where are you thinking?
It'll probably be a Friday, so it'll be what, April?
Same
Today's
time,
7th, right? So
from 10 to 10:30. I think.
yeah. So let me see. It's probably gonna be on April 20th. No, 19th.
So it's gonna be on the gas basically on the
Yeah,
gas stuff.
everything before.
Everything.
Uh-huh.
Yeah. All right. That's good. You know. So, but this exam doesn't really seem like it's gonna be too bad though. But still, I want to make sure I'm ready.
I mean, usually students do struggle with this exam, so you want to make sure you put in a lot of effort.
Yeah, that's what I'm saying. I still want to put in an effort though. Like
Uh-huh.
seeing as though even on
Students
my
do
quizzes
find
and
this
stuff,
exam
I
more
still.
challenging.
Yeah, that's what I'm assuming though. I mean, I'm not saying it's gonna be super easy though, but
Yeah.
I'm gonna have to put a lot of effort and even probably do problems from the textbook this time. You know, that way you
Mhm.
understand it.
Right.
Do people find your final challenging amount or no?
Yes, they do.
How many questions does your final normally consist of?
Yeah, we'll talk more about that once we get there. It's not decided yet. Yeah.
The same questions will be on this like the same amount of questions will be on this exam like the last one, like 20,
Yeah.
25
Yeah.
multiple choice, then they're gonna be working on your points, right?
Right. Should be close.
Okay. Well, it should be, it should be doable though. We have to put a lot of effort into it. I hope so. It seems
Uh-huh.
like it though. You said I'm putting a lot of effort into this stuff,
Mm-hmm.
so that.
That's good.
But now you said like 19 and 20 are still the stoichiometry problems, right?
Right.
Now for like 20, what I'm looking at though is like, since we already have leaders in the atoms and you know degrees Celsius, but I'm changing that to Kelvin, as I can see. So are we
Right.
trying to find like the second volume, because we have one volume already, because it says
Right.
and 35 degrees Celsius is blank liters. So it's basically asking for a second volume.
It's looking for a volume of the hydrogen gas, so volume of hydrogen, H2. So you're given the volume of one of the gas is given to you, and you have to find it for the hydrogen gas.
Okay. I think somebody just joined too.
Right.
If they have any questions.
Yep. Aida, do you have any questions? We're not connected, or they can't hear us.
Ask her to type in the. Let me see if she's in the messaging. Let me see if she's in the messenger board or something.
That's okay. You can continue asking your questions, Nick.
Yeah. Okay. So go back to the screen real quick. There you go. Okay. So for this one, I'm trying to find the volume of gas. You said, right?
Right. So you're looking for the volume. So the volume of HCl gas to react with the excess magnesium. So this is HCl, and you're given that you have 6.82 liters of this.
Right.
Oh, no, I'm sorry. The volume of hydrogen gas, what you have to figure out, is required to react with excess magnesium metal to produce 6.82 liters of hydrogen gas. So for H2, you're given that it's 6.82 liters, and you're given the pressure, you're given the temperature. So, and you have to find the volume for HCl. Did the question make sense to you?
No, it really. Because the thing I'm confused is like, what am I supposed to plot out first for the PV equals nRT formula? Because that's where we're getting stuck.
So, right. So you have to first find out. Do you understand? No, do you understand the question, not the solution, but do you understand what the question is trying to say?
Is it trying to it's giving me the volume of HCl, like how you said, right?
No. That's not what I said.
Okay.
You tell me what it's the question saying, because that's very important for you to understand. So it's the question saying the volume of HCl gas required to react with excess magnesium. So it's saying that the HCl is reacting with excessive magnesium to produce, you folks see that word? To produce 6.8,
to make, basically.
to make, yeah, so it's making 6.82 liters of what? Of?
Hydrogen gas.
Which is H2.
Right.
So you're given 6.82 liters of hydrogen gas, not HCl. And you're given pressure for H2. You're also given temperature for H2. So you have P, V, and T. So what do you think you can find from here?
We have PV, and don't we have L also, or no?
What's L?
The 6.82 liters.
That's a volume, right?
Yeah.
So
Or
that's
I'm
what you're
trying to
saying.
say
We have
T.
P,
Sorry.
V, and T, so we have all three of them.
Mhm.
What do you think we should find?
P. Don't we need to find moles?
Right.
Because
So
we
if
don't
you
have
can find the
moles.
moles, right? So if you can find the moles of nitrogen, oh, sorry, hydrogen.
Mhm.
So if you have the
Right.
moles of hydrogen, can you go to moles of HCl?
The moles of hydrogen. Yeah, can't we do that basically? Moles of
Yeah, you can,
HCl?
right? Mole to mole ratio,
Yeah. Yeah.
right? Now, once you have the moles, what is the question looking? Question is looking for volume.
Right.
So how will you find volume? Can you change moles to volumes? You're again going to use PV is equal to nRT.
Yeah.
Right? Because your
Yes.
pressure stays the same, your temperature stays the same. You're going to use the same pressure, same temperature, but you're going to use the moles of HCl that you figured out from the moles of hydrogen. So from moles of hydrogen, you will go to moles of HCl. Once you have the moles of HCl, use the equation PV is equal to nRT for the second time. That makes sense?
Mhm.
So the first time you have already used PV is equal to nRT to find the N, and this is for hydrogen gas, okay?
Okay.
This is for hydrogen gas. Okay. Now, once you have the moles, once you have the N for hydrogen gas, you go from moles of hydrogen gas to the moles of HCl. Right? Mole to mole ratio.
Right. Mm-hmm.
So once you have, that makes sense, right?
Yeah. Yeah, it kind of does. Yeah.
Okay, so first you got to understand what the question is saying, okay? And after that, you have to figure out the solution. So the question is saying
Mm-hmm.
that if I already know how much hydrogen gas I have, then how much HCl do I need? That's what the question is looking for. Okay?
Mm-hmm.
So first
Right.
you need to find the moles of hydrogen gas because you're given P, V, and T.
Right.
And R is a constant. So you can just plug in the numbers and get your N. And that will give you the N for hydrogen gas. From N, which is moles of hydrogen gas, go to the moles of HCl by using mole to mole ratio given the balance equation. It's a 1:2 ratio.
Okay.
Now you have the N of HCl. From the moles of HCl, so you have the moles, you have the R, you have the temperature again, 35, because the temperature is staying the same, right? It's not saying that the temperature was different earlier, it stayed the same.
Mm-hmm.
So you have the T, you have the R, you have the N, you have the pressure 2.19 atm. Can you find V?
Right.
Can you find V if you have all of these other numbers? So V will be equal to
Yeah.
nRT over P. And you have to just plug in all the
Yeah.
numbers. But make sure here you're putting N of HCl because you're finding V of HCl.
Right.
Okay?
And then once we plug in the moles of HCl and the R formula
And T and
and the
P, you should get the
temperature.
V. Yeah.
Okay. And that'll be basically my final answer, right?
Right. Again, don't look at these as just finding the answers. Actually try to make sense out of them. That's when
Well,
you'll understand it
exactly.
because you're not going to have exact same question on the exam. You're going to have a different question.
Yeah, that's what I was trying to exactly say
Right.
what you just said because this isn't going to be on my exam, but I want to understand this because there's going to be questions
Right.
like these on
Right.
my exam.
Right. Right. But if you're able to do the other stoichiometry question, this is a similar stoichiometry question. The only difference is you're not given mass. Instead, you're given PVT to find the N instead of you being given mass to find the moles. That's
Okay.
how previous questions were different from this question. right?
Right. So, but yeah, I was just wondering about that. So you said to do these and do also our textbook questions. They should be fine for this exam, right?
Yep. What's important is not just doing questions, but you actually
But
understand them.
understanding them,
Right, right.
because it makes sense, because you could do a whole bunch of questions and you go on the exam and you're still not
Right.
understanding what the
Right,
questions
right.
they're asking on the exam.
Right. Exactly.
So
Hey, Edith, do you have any questions? We just saw you join later.
It's kind of late, but yeah, I've been listening to.
Yeah.
Not really right now.
But if you have questions on the gas law virtual lab, that's that we discussed earlier, and once I'm gonna upload this on YouTube, if you wanna watch that, you can do that as well. But if you have
Yes.
any questions, let me know. Okay.
Okay. Thank you very much.
Uh-huh. Hey Nick. Yeah. So we got the last 2 minutes. So if you have any final questions.
So 21 through 26 are similar to the problems that you made the announcement on for the, or
No, they're different.
right.
Yeah, they're different questions. Yeah, we did
Because
cover
the
them on
question is-
Wednesday, but they're
Right.
a little different.
Okay. Are you like 50% different or like 25%
No. See,
different?
the slide question that I uploaded, the one that we were thinking about,
Yeah.
it does talk about partial pressure, so it has some similarity. I don't want to measure how much similarity, but you first gotta study these questions. That's when that question will make sense.
Okay,
But
so
then
that's when
go by the lecture questions, go by the how we covered them in the lecture. Do it in that order,
Yeah.
and then they should make sense.
Okay. Then I can do the rest of these multiple choice questions and textbook material and stuff once I understand this.
Uh-huh.
All right, that makes sense. I just can't believe how fast the day went already. So crazy. So
Right.
you'll be available, right, in your office?
What's that? Yeah. On Monday and Wednesday.
Yes. Because I want to swing by and make sure my lab is looking good with you, so that way I'm not rushing till Friday to get it done.
Sure.
Well, I appreciate it. Well, I'm sure you have to go now because it's going to be
Yeah.
11.
All right, guys. So yeah.
All right, this will be on YouTube, right?
Yes. I'll upload that once it's rendered. Okay.
All right. Thank you, Amon.
All right. See you guys.
Thank you, Amon.
Bye.
Bye.
Have a good
All right.
day.
Yeah.
Bye.
Bye. You too.